Welcome to Newton's second law of motion, law of acceleration. Sir Isaac Newton was an English mathematician, astronomer, physicist, and philosopher. As we learned in the first law video, Newton's revolutionary work during the late 1600s set the stage for how today's scientists understand the physical universe. His first law predicts how objects behave when forces are balanced. His second law tells us how objects behave when the forces aren't balanced. The acceleration of an object is directly proportional to the net force and inversely proportional to its mass. The second law is dependent on two variables, the net force in action and the object's mass. As the force increases, so does the object's acceleration, and vice versa. Also, as the object's mass increases, the acceleration decreases, and vice versa. Back to our apple orchard. Newton's second law gives us the relationship between the size of the force and the resulting acceleration. If your little brother throws one apple in the orchard, it goes this far. If your little brother hauls in a catapult and uses it to throw the same apple, it leaves the orchard, crosses the road, and ends up in the neighbor's field. The catapult uses a much larger net force to apply more acceleration to the apple and send it flying farther. Much, much farther. The other part of Newton's second law, as the object's mass increases, its acceleration decreases, can be demonstrated in the same way. Using the same catapult, your brother can send a giant pumpkin flying a much shorter distance than a tiny apple. The pumpkin has a greater mass, so the acceleration is smaller. The catapult could send an apple tree even less far. The larger the mass, the smaller the acceleration force. Unlike your brother's rather unscientific demonstration, Newton's law can be written as a mathematical formula. Combining the effects of net force, mass, and acceleration turns into acceleration equals net force divided by mass, or net force equals mass times acceleration. You can use either of these formulas to find the missing variable in algebraic problem solving. In summary, Newton's second law states the acceleration of an object is directly proportional to the net force and inversely proportional to its mass. Now, find out how your little brother got hold of a catapult. Newton's second law, the law of acceleration.